What's going on, everyone? Hope you guys are doing fine. So I've been catching these debates online on TikTok.
Oh dear, once again flatearthbanjo have found his information on TikTok. This will be stupid.
First of all, I want to give all the credits to Angels of Light. He's the one who has been debating these globe believers. So shout out to you, give him a follow if you are on TikTok. So these guys, they don't think of their own, like they have been instructed to deny that the speed of the earth is roughly 1,040,000 miles per hour at the equator, 1,600 kilometers per hour at the equator. So they have all been instructed to deny this, and they use numbers like rotations or degrees.
I haven't seen anybody denying it who have some kind of knowledge about it, but the number is not relevant.
So this video is going to be to address this. We're going to be listening now a couple of professors, university professors, and since I was a kid I have learned the speed of the earth in kilometers in Brazil, 1,600 kilometers per hour at the equator, and I can say this is the same in different countries, different languages. We all have learned that, but now they have been denying this very fact. So let's go ahead and take a listen to these guys stating that the speed of the earth at the equator is in fact 1,040 miles per hour or 1,600 kilometers per hour.
Well, I mean, NASA doesn't have to perform an experiment to prove that it's moving at 1,000 miles per hour. You can figure out that at the equator, the Earth is moving at about 1,000 miles per hour from a reference frame that is outside of the Earth.
So godless engineer is a professor. Didn't know that one.
So the equator is about 25,000 miles around, and it takes 24 hours for one full rotation. Okay. So if you divide those two numbers, you get approximately 1,000 miles an hour.
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
Or 465 meters per second.
As we know that it's turning 24 hours, the circumference around the equator is about 24,900 miles. And we know it rotates once every 24 hours. So you just divide 24 into 24,900. It comes out to 1,037 miles an hour.
Distance is equal to circumference of the earth, and time taken is equal to 24 hours. So when we calculate, it becomes 1670 kilometer per hour.
Since the circumference of the Earth is roughly 25,000 miles, and it takes 24 hours for one day to happen, 25,000 divided by 24 is roughly 1,000.
1,041 miles per hour.
As the Earth rotates, the equator is going the fastest. You're going about 1,000 miles an hour.
So there you have it. So let's go ahead and start listening to these debates, and I will be commenting on as we go along.
Quickly, shut up. How fast does the Earth rotate at the equator in your model? How fast in miles per hour?
In miles per hour? Well, here's the thing. We don't measure rotation in miles per hour.
At the equator, the Earth is moving at about 1,000 miles per hour.
So here's the thing you want me to say, so I'll go ahead and say it.
What is the speed?
We'll go ahead and say it. I'll just go ahead and say the thing you want me to say.
Yeah,
it's 1,000 miles an hour.
Okay.
How about that?
And how much is that?
Is that what you want me to say? 1,000 miles an hour?
Yeah. How much in 1 second, Jada?
No, I don't know. I'm not going to calculate that off the top of my head.
You
calculate it off the top of your head.
1,500 feet.
All right, cool. Who cares?
The whole scientific community?
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
This is a video from the Concorde airplane, the fastest passenger jet. Look at the food here, quite still, and in the glasses it was still. And Mach 2, 1,310 miles per hour. If you travel in a constant speed, you don't feel the speed. You feel changes in speed, acceleration, or if you're braking.
Second.
So if I throw a ball up for 1 second, does it deviate?
Does the ball go up?
1,500 miles per hour?
Conservation of momentum.
Oh, so now there's no Coriolis right now. Thank you. You just debunked Coriolis. Thank you. So the ball does not deviate. There's no Coriolis effect to prove it then. Thank you, Chada.
No,
Thank you,
you literally said the ball deviates.
Coriolis effect, an effect whereby a mass moving in a rotating system experiences a force, the Coriolis force, acting perpendicular to the direction of motion and to the axis of rotation. On the Earth, the effect tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern.
Coriolis. You don't know what Coriolis is, you
said conservation of momentum.
Yeah, conservation of momentum. So I'm standing at the equator, I throw a ball up and it doesn't fucking move anywhere, right? But if I...
Let's look at the planetary rotation. Does that
Does
that not engage with a field kick?
So if you have a north-south stadium, and many are, if it's oriented that way, and the kicker kicks the ball, depending on how high and how long it's in the air, the rotation of the Earth can have a significant effect on its trajectory towards the goalpost. If you're trying to make a 50-yard field goal, that's far away enough, and the ball is airborne long enough for the rotation of the Earth to deflect it to the right by 1/3 of an inch.
I throw a ball up, straight up in the air at the equator, it lands back in my hand.
Have some more fluoride water. You're just yelling at me.
No.
Okay, check this out right now. If I throw the ball north at the equator, does it deviate 1,500 feet sideways?
This is not a debate, this is a dumpster fire. Because the atmosphere is following the Earth rotation, but not perfect.
The further away it travels from the equator, the further towards the right.
Okay, so Ranhan, now that I've thrown the ball forward, right, it doesn't deviate 1,500 feet, right, Ranhan? It doesn't deviate 1,500 feet sideways? How come, Ranhan? Go on, say conservation of momentum again. Disprove Coriolis again.
And nobody claims that.
If a soccer match is taking place right at the equator where Earth spins 460 meters per second or 1,500 feet per second from west to east, would the player be able to score, or would Earth under the ball spins from west to east? If the ball is moving with the Earth, then Coriolis effect does not exist.
That was Banjo's commenting. He often uses AI voices and so on, and he proves he don't understand what he's tried to discuss and tries to prove.
If the ball travels 3,000 feet in 2 seconds and Earth under the ball is moving from west to east at 1,500 feet per second, that means the ball would land 3,000 feet to the side of the goalpost.
And he's wrong. Why don't flurfs try to understand the things they try to debunk? Because that have nothing to do with Coriolis. What he's describing is his own fantasies.
And I tweeted, the winning field goal in that game was aided by a 1/3 of an inch deflection to the right from Earth's rotation.
Banjo don't understand the difference between 1/3 of an inch and 3,000 feet. Oh dear.
Documents say non-rotating and the pilot does not have to adjust for Coriolis. Were you wrong by saying that that's just for simplification?
False premise. I said the pilot does have to adjust. He just doesn't notice because it's a tiny hair's breadth.
Was it a tiny bit when the Earth rotates at the equator 1,500 feet per second?
In the beginning of the video, Banjo was talking about globers that didn't want to admit the speed that the Earth rotates and so on. But where are the evidence for that? He presents stupid flat Earth nonsense from fools that don't understand the things they try to debunk.
Because it's relative to the ground. It's not. You can't take an absolute linear movement and equate that.
Number 5. I just denied Coriolis 5 times. Okay, check this out. If I hover a drone above a spinning merry-go-round, does the merry-go-round spin underneath the drone?
Okay. Have you ever worked a blender, Angel?
How about if you answer my question?
And once again, this fool proves that he don't understand the things he thinks he's debunking.
No, it doesn't, because the merry-go-round is not moving the air around it.
Okay,
that drone is
now,
coupled to the air, which is coupled to the Earth rotation, not the rotation of the merry-go-round. This is a bit
correct. So
right?
now
Is that true?
Yes. So now,
right, when you spin a merry-go-round, does the air around the merry-go-round swirl around and everybody starts to fly towards it?
Hang on 1 second.
No,
so
it did not.
Okay.
The merry-go-round is actually a good example of Coriolis. Try to throw a ball
because it's actually
in the merry-go-round across the way.
Yeah, so why does it work?
Coriolis.
Why does it work with a ball but with not a drone?
Oh dear, look at his smile. He thinks he's smart and he don't understand how wrong he is.
Yes, the atmosphere is coupled to the Earth. Just like when you turn a blender on, eventually all of that stuff starts spinning.
We have learned that air particles are independent from each other. What's inside a blender is normally liquid or solid like ice cubes. This professor cannot compare a gas to solid or liquids. See as this girl jumps into a pool full of independent plastic ball. Her jump does not affect the other side of the pool.
And the stuff near the blades is spinning at the rate of the blades, but it doesn't start that way. It takes a little bit of time.
Because he just said that the Earth, the atmosphere is velcroed to the Earth. How come clouds move in all directions? And they're part of the atmosphere.
So, relative to the ground, they're not moving that fast, but there are local disturbances in the atmosphere, man. We're not saying that the atmosphere is a rigid body. It is a gas. Right? This is a gas.
So again, does the helicopter velcro itself to the atmosphere?
The helicopter, when it is on the surface of the Earth, it is moving with the Earth. So it has that velocity, that inertia. So when you lift it up, it still has that velocity and it has inertia. It's going to stay there. And since the wind is moving with the Earth, there's nothing to deviate it.
So, it's just like saying Earth is stationary and only things that are on Earth are possible to measure speeds, but not Earth itself.
This nonsense discussion goes on and on and on. And Banjo don't understand how stupid those flat earthers are. And he definitely don't understand how stupid himself are. Oh dear. Okay, that was all for this time. I will be back soon. Have a nice day. Bye.